So in this question, we want to figure out what the hybridization is around the I in this ICl4 with the negative charge. And in order to do that, we have to draw the Lewis structure. And to get the Lewis structure, we need to look at the periodic table. So here's a picture of the periodic table. And what you need to know is you need to know where the valence electrons are. And everything that's going to be in this column right in here is going to have 8 valence electrons. And everything in this column right here is going to have 7. Everything in this column right here will have 6. This column right here will have 5. This column right here will have 4. And this column right here will have 3. And for right now, we're going to skip this column right in here. And then this column right here will have 2. And then this column right here will have 1. And you have to watch out because helium right here, helium only has 2 valence electrons. And so you need to watch out for this helium right here. And now that we know where all the valence electrons are, we can start to draw this Lewis structure. Now, to draw the Lewis structure ICl4 with the -1 charge, what we're going to do is we're going to put the I right here in the middle. And the reason why we're going to put this I right here in the middle is because I have fewer of these I's than of the Cl. Now, because the I is going to be in the column that's got 7 valence electrons, normally this I would only bond 1 time. But because we have 4 Cl's, I'm going to make this I right here, this iodine, bond 4 times and once to each of these Cl's. So what I'm going to do is I'm going to put a Cl here, and that's a bond there. And then I'm going to put the Lewis dots around here, and I'll put 6 of them because Cl has 7 valence electrons, and so I have 1 valence electron in here, but this valence electron is what's going to make this bond right here to this I, and so I'm going to put 4 of those down, and that's going to be all the Cl's here bonded to this I right here. And now that I got 4 of them like this, what I have is the Cl will normally bond 1 time because it has 7 valence electrons, and so does this I right here. It's got 7 valence electrons, but I had to bond it 4 different times because the chemical is ICl4. So what I did was I essentially just tried to make the Cl's or the I's only bond once, but I had to put the I in the middle because I have these different 4 atoms in here. And so that tells me that this I right here is going to be a little bit different than what you would normally see. And so whenever you get a problem like this, where I have this I right here that doesn't look like it normally does, which is 1 bond, what I'm going to do is I'm going to write down the formal charge equation. And the formal charge equation says that the number of valence electrons minus how many bonds you have plus how many, I'm going to put free electrons, but or this can be lone pairs, so free electrons. And so what I'm going to do is, because this is a -1 charge right here, that means that I need to have a -1 on this Lewis structure in here. And the place where I'm going to put that -1 is going to be on this iodine right here. So I need this I not only to have 4 bonds, because it has to have 4 bonds, but it also needs to have a -1 formal charge. So what I'm going to do is I'm going to put a -1 here for the formal charge, and this is the formal charge of this I right here. It's not the formal charge of the Cl's. I could use this equation for each of these different Cl's in here, but if I did that, it would just essentially be 0. And I know it's going to be 0 because this is how Cl normally looks. And so I'm going to focus on just this I right here. And so I want to have a -1 charge, and it's going to be equal to the number of valence electrons for I. Well, that's going to be 7. And then I'm going to subtract how many bonds I have. Well, I had to make 4 bonds. I didn't really have a choice in that. So I'm going to put 4 bonds there, and then I'm going to do plus the free electrons. And so I'm going to solve this equation right here for the number of free electrons, and that will tell me how many Lewis dots I have to put on this I. And so what I want to do is say -1 equals, we're going to have 7 minus, now to get a -1 here, I have to have an 8 here. So this right here, this 4 plus free electrons, that's going to equal this 8 here, and that's how I get this -1. So that means if I have 4 right here, it means the free electrons has to be equal to 4. So the free electrons, that's going to be equal to 4, or 4 dots. So I'm going to put 1, 2, 3, 4. So I essentially just put 2 lone pairs, or 4 free electrons, or 4 dots. And now what I'm going to do is, in order to figure out the hybridization, that I'm going to count the number of domains that are around this I right here. And so the domains, that's going to be equal to either a lone pair, so I have a lone pair, or it can be a bond. And the bond that it can either be a single, double, or a triple. And so if I have 1, 2, 3, 4, that's 4 domains for the bonds, and then I have 5 and then 6. So I have 6 different domains around this ion here. And so I have 6 domains. And if I have 6 domains, that can help me figure out what the hybridization is. And so what I'm going to do is I'm going to say that if I have an S and a P, and the P has an X, Y, and a Z, or it has 3 different orientations, X, Y, and Z axis. So I can have one S and then I can have 3 P's. Well, that I have 3 P's and then one S. That's going to be for 4 hybridized orbitals, and I need to get 2 more. And so what I'm going to do is, after I go from an S to a P, I'm going to go to the D orbital, and I need 2 D's to finish out to get this 6 domains here. So I have 1 S, 3 P's, and 2 D's, and this will be the 6 domains that are going to be hybridized in order to get right here. So this right here will be a hybridized orbital. This is a hybridized orbital. This is hybridized. This is hybridized. They're all hybridized. So the hybridization of this I right here is going to be sp3d2.